Hello, welcome to Wega Achieva Educational Limited, presenting We Are Tutor, trusted for being friendly and high impact learning. Today, looking at Paper 1, AQA GCSE Chemistry Overview. These are the list of topics you are expected to cover: atomic structure, periodic table, quantitative chemistry, chemical change, and energy change. Our topic today will be the periodic table. What is the periodic table? The periodic table is a table that deals with how elements are arranged in order of increasing atomic number, which is proton number. Elements with similar properties are placed in vertical column called group, and elements in the same group have the same numbers of outer shell electron, which is called the valence electron. Let's quickly talk about how elements are arranged in this periodic table. You can see that the vertical column involve the group, which are from group 1 to 0, and the horizontal involve the period, which is period 1, from hydrogen down to francium. Now, that is the first structure of the periodic table that shows the group and the period, and here's the overview of the periodic table. Now, let's talk about the early periodic table. In the year 1865, an English scientist, John Newland, proposed his law of octave, where he arranged the elements in order of their atomic mass. Newland noticed that every 8 elements had similar chemical properties. Now, this then broke down after calcium was discovered in the periodic table. Now, you can see that according to the early days, elements were classified based on atomic weights, according to Newland. Then, in the modern periodic table, elements are now classified based on the atomic number. Before we talked about that, let's talk about Dmitry Mendeleev arranged elements by atomic mass, but on his own arrangement, he left gaps for undiscovered elements, so that elements that have not been discovered, when they are discovered, they can fill in those gaps. That is why he actually left space in the periodic table. Now, I will say that. Let's talk about Mendeleev's prediction. Now, Mendeleev's prediction is very easy. Now, like I said in the previous slide, it's actually left gaps there. Now, Mendeleev left gaps for new elements and predicted their properties. Now, in his prediction, it was later proven correct, were explained and were constructed. Now, Mendeleev's prediction then leads to explain the inconsistency by changing element order based on properties. Now, let's take our mind back to the discovery of subatomic particles. The discovery of proton, neutron, and electron, which are subatomic particles, in the early 20th centuries, explain that elements were recorded by atomic number. Now, during this process of this discovery, whereby the element was being recorded by atomic number, this also explained the reason why the order of atomic weight was not always correct. Yeah, this also explained it perfectly well. This will now lead us to the modern periodic law, which then says that elements are ordered by atomic number, and also groups and period organize elements with similar properties. That's the truth. And in this process, they tend to reflect the periodic trends like reactivities of those elements and the atomic radius, which will be discussed later on as we progress in our study. Now, let's talk about some elements that are present in the periodic table, such as metals and non-metals. Now, what are metals? Metals form positive ions, which are called cations, meaning they tend to give out electrons, or rather they tend to lose electrons, and they are found on the left and bottom of the table, that is of the periodic table. Why non-metals do not form positive ions and are found in the right top of the periodic table. Now, note that metals conduct heat and electricity, and non-metals do not. Now, I will show you a periodic table that shows how metals are classified and non-metal. Here is the table, and we can see that the blue colors shows the metal metalloid are the green, and the non-metals are the yellow. Just like I said in the previous slide, Metals are the left and non-metals are the right. When you hear the word metalloid, these are elements that behaves like they exhibit both metallic and non-metallic properties. Yeah, they have both sides. They are neither here nor there. Meaning they have some properties of metals and they also have some properties of non-metals. So that aside, let's move to the next slide. As regarding your GCSE exam, so let's talk about group 1 elements, which are metals. That's the alkali metals. That is to say, group 1 elements are popularly called alkali metals, and know that they have one outer share electrons. They are soft metals, react vigorously with water, and also they form alkaline solution and hydrogen gas. Now they also react with oxygen to form oxides and chlorine to form white chlorides. Now the reactivity increases down the group, meaning as you go down the group in group 1 metals, their reactivity increases down the group. Like here are the group 1 elements, which begins with lithium, sodium, potassium, rubidium, cesium, francium. Meaning as I go down the group, the reactivity increases from lithium down to francium, which means according to that statement, francium is more reactive in that group. Now I know you must be wondering why hydrogen is not present there. Note, hydrogen is not a metal due to the fact that it has one valence electron, that is one outer share electron. That is why it's placed in group 1, just for convenience's sake, like okay, it should just be there since it have one. Yeah, but it does not exhibit the properties of metals, the properties of metals. Yeah, here is a summary of group 1 reaction. Like lithium bonds with a red flame, steady fizzing with water. Sodium bonds with an orange flame, melts into a ball and reacts rapidly, while potassium bonds with lilac flame, ignites with sparks, most reactive of the theory. Now you should take note of that. Those are the major ones you need to know for now. I haven't talked about group 1 elements. Another one on our list to spots is the group 7 elements, which are also referred to as the halogens for your GCSE exam. The halogens. Now the halogens have 7 outer electrons. They exist as their atomic molecules. Examples: chlorine, bromine. We also even have fluorine and iodine as an halogen. They react with metals to form halides, and they also react with non-metals to form covalent compounds. That is one feature of the halogen. And here is the structure, or rather the periodic table showing the group 7 elements. Now you can see we have fluorine, chlorine, bromine, iodine, and astatine. Those are the group 7 elements. Now let's talk about the trends in group 7 elements. Now as you move down the group, the melting and boiling point increases and reactivity decreases because outer electrons are further from the nucleus in group 7 elements, and they harder to gain electrons lower in the group. It simply means that as you move down the group, the rate at which they react decreases. So hence, fluorine is more reactive than chlorine, and chlorine is more reactive than bromine, and bromine is more reactive than iodine as you move down the group. Astatine is least. So let's talk about the displacement of halogens. In the displacement reactions of halogens, a more reactive halogen displaces a less reactive halogen from its source. Examples: chlorine plus potassium bromide. Since chlorine is more reactive than bromine, it will displace bromine from potassium bromide, forming potassium chloride, and bromine will be liberated. That is how it is done. So the highest reactive will displace the least reactive. Now, I haven't talked about that. Let's go talk about another exam focus again in our GCSE, which is what? The noble gas. Noble gas are elements found in group 0. They have full outer shell, that's to say their outer shell is completely filled with 8 electrons except for helium, which have 2. They are very stable and unreactive. They exist as a single atom, that is monoatomic, and their boiling point increases down the group. I haven't talked about that. Properties of noble gas. Noble gas are used in light, wording, and cooling, and their density and boiling point increases as atomic number increases, further as atomic mass increases. Now, these are examples of the noble gas family, which include the helium, neon, argon, krypton, xenon, and radium. Those are the noble gas family, which are in group 0. Now let's talk about periodic trend and summary. Group 1 elements, reactivity increases down the group. In group 7 elements, reactivity decreases down the group. In group 0, they are unreactive and they are noble gases, meaning they are also referred to as inert gases, not being active. I will talk about that. Let's talk about cooperation periodic table. Group 1 alkali metals, group 7 halogens, and group 0 noble gases. You can say group 1 forms a positive ion, one positive ion. Group 7 form one negative ion, and group 0 have no charge because they are unreactive. And group 1s are solid at room temperature, while group 7 are gases, liquid, and solid at room temperature, depending on which of the halogen. So thank you very much for joining us there. Now let's talk about the last one, which has to do with the periodic law. According to the periodic law, it says that you focus on the properties of an element repeat periodically when arranged by atomic number, and this also explains repeating patterns of reactivities and bonding. Now let's answer some Gsce questions. Time to answer some questions from AQA Gsce past question. The first question already says, what is the name of the element in group 0 of the periodic table? This is way too simple. Alkali metals, halogens, noble gases, transition metals. The answer is what? Noble gases. I said it in the slide. You can go back and actually study it very well and come back and answer it. So the next question only says, which statement about the elements in group 0 is correct? 1 says all elements in the same group are very reactive. That's wrong. All elements in the same group form negative ions. That's wrong. The boiling point increases down the group. And lastly, the relative atomic mass decreases down the group. Anyways, the last one is wrong. The right answer to that question is the boiling point increases down the group. You can go to the previous slide and you see there. The next question says, neon is in group 0. What type of particle are in a sample of neon? Is it an atom, is it an ion, or a molecule? It is an atom. An atom is the best answer. The next question on our list is figure 1. Shows the position of 6 elements in the modern periodic table. Which one of these 6 elements? The answer to this particular question is hydrogen. Hydrogen is the one with the lowest body points. Now, let's go to the next question after this. The next question says, complete the sentence. In the periodic table, rubidium is in group what? This is way too easy. I think the only difficult question right there, which we were not told in the slide, was the boiling point of hydrogen, which is the lowest. According to this answer, the answer is rubidium is our answer. Rubidium is our answer to that previous question. And as for this one right here, this last question, which of these 3 elements is the most reactive? Which of these 3 elements is the most reactive? Without being told, is potassium. Potassium is more reactive than sodium, and sodium is more reactive than lithium, so potassium is our answer. Thank you very much for joining us at Vega Achieve Educational Center. God bless you. Thank you.